Hello everyone, my name is Simone Bertolazzi. I'm Principal Analyst at Yole Group. I joined the company in 2018 covering emerging non-volatile memory technologies such as phase change memory, resistive RAM, MRAM, and then I started covering all the different memory technologies including NAND flash and DRAM. Today I would like to talk more particularly about DRAM technologies as we recently released a report called Next Generation DRAM 2025, focus on HBM and 3D DRAM. So we have two major topics in this report. The first one is HBM. It's a booming market. High bandwidth memory is a key technology for AI applications, and the major suppliers are really investing heavily in these technologies, supplying major processing companies such as NVIDIA, AMD, but also hyperscalers that are involved in the AI business. The second topic of the report is 3D DRAM. So we cover the DRAM technology roadmaps in the short term with continuous planar scaling, but also we project that starting from 2033-34, it will be necessary to introduce an architectural transition from 2D to 3D. It's very similar to what happened in the case of NAND technology back in 2014-15 when a transition happened from 2D flash to 3D NAND technologies, and the era of layer count scaling started. In 2025, DRAM suppliers have been ramping up the production of the 1C or 1 gamma DRAM technology that is based on the 6F² DRAM cell. This cell geometry is optimized and has been scaling for several years, but today there are challenges for continuous scaling of these technologies that relies more and more on advanced lithography, such as, for instance, EUV lithography, which is an expensive but very effective approach for implementing high-density DRAM and next-generation DRAM technologies in general. However, due to these scaling challenges, companies are also working on different architectures, in particular the 4F² cell geometry. This is a further optimized cell geometry that enables further scaling and enables reducing the footprint thanks to the use of vertical transistors. So there's clearly a shift here in the geometry, and this would enable density gains in combination with the second approach that is also key, that is CMOS bonding. Once companies will decide to move to the 4F², they will also need to adopt a new approach, which is the CMOS Bonded Array architecture that is already utilized in the NAND technologies. As I mentioned, in 2025, companies are working on the 1C, 1 gamma technology. We do believe that they will continue scaling with normal planar approaches, including more EUV layers for 1D or 1 delta, and possibly also 1E or 1 epsilon technology. This remains to be seen. But starting from 0A, so the first node of the 0 nanometer class of technology nodes, it will be necessary to adopt a new approach. And here we believe that the use of 4F² and CMOS bonding will become necessary. There's a clear challenge that needs to be addressed here for implementing 4F² and CBA, CMOS Bonded Array, which is actually the requirement for high precision in the alignment of the CMOS wafer and the DRAM array wafer. So this pushes bonding technologies to their limits, and new forms of bonding probably have to be used, and we believe at Yole that fusion bonding could be a clear approach for implementing these architectures. Yole Group, we definitely look into the technologies. We have an activity for analyzing DRAM devices. We do reverse engineering and reverse costing of DRAM technologies, including all the leading edge DRAM technologies. And we do perform the market analysis through a comprehensive interview campaign. We can interact with the major leaders and gather information that is not available anywhere else, only thanks to the interactions with the players involved directly in this business. The DRAM market is well consolidated. We have three major players that are Samsung, SK Hynix, and Micron, that are developing the leading edge DRAM technologies. We have other players that are also involved in the DRAM business, including companies in Taiwan, such as Nanya, Wimbund. We have other companies in China that are rising, such as, for instance, Changxin Memory Technology, CXMT. So all these companies are trying to progress in the development of their DRAM technology, with the three key players that I mentioned earlier being at the leading edge and currently developing the 1C, 1 gamma, but with the potential to developing next generation 4F square technologies by 2029, 2030. We have seen there are opportunities to keep scaling the technologies to some architectural transition, 4F square, CBA. Then we can continue scaling through the adoption of more EUV, and possibly, if companies will not adopt this 4F square architecture, then scaling will be enabled by technologies such as, for instance, high-NA EUV, so that will be used for implementing the smallest feature in the DRAM devices. We do expect that continuous scaling to increase the density and also the performance of these devices will be possible, but at a certain point we'll reach a saturation. It will not be possible to continue scaling. This limitation is expected to arrive by 2033, 2034. At Yole, we believe around the 0C node, companies will be obliged to find alternatives. And the main area of work today is actually 3D DRAM. We are not talking about stacking multiple DRAM dies or wafers, but we are talking here about monolithic DRAM in the sense that the array is implemented vertically, like it happened in the case of 3D NAND. Of course, wafer bonding also in this case will be necessary for bonding the logic part, the CMOS wafer, and the DRAM array wafer. So there's an opportunity here for equipment suppliers involved in bonding, but also for equipment suppliers that are heavily involved in etching or deposition, because 3D DRAM will require more and more of these systems for deposition and for etching. At the same time, 3D DRAM could relax the requirements for lithography, but definitely they will move and they will shift the mix of equipment towards deposition and etching. The entire memory team of Yole Group will be present at the Future of Memory and Storage, FMS, and we will present our latest results in terms of market research. I will personally present part of the work that we did for next generation DRAM. I will cover HBM technologies and also 3D DRAM and all the opportunities that are present today in these fast evolving businesses. All these technology changes that I mentioned and all these fast-moving markets require continuous monitoring of all the activities. And at Yole Group, every day we monitor these evolutions, and we can provide to you updates regarding these dynamics in our products, and also in our website you can find continuous information and updates. Please follow us on LinkedIn and on www.yolegroup.com. Thank you for watching this video.